we will talk about hematomas, bruises, and petechia in poultry. This is Pako Fernandes from Zinpro. And we have to consider that the capillary network is just made by one single layer of cells. So you can imagine it's very sensitive to everything that increases vascular fragility. And also you have to consider that these cells in the endothelial monolayer tissue are held together by tight junctions that are Velcro-like structures that keeps the cells together. And these tight junctions are very sensitive to stress. So when you have basically all types of stress, you increase vascular fragility and you will see a higher amount or incidence of hematomas and bruises in the slaughterhouse, including, for example, heat stress. A typical issue is the blood splash. As you can see here, blood splash has different reasons. The typical one, or the most common, is electrical stunning, high intensity. That means high voltage, high amperage, and low frequency. So if you want to reduce that, obviously you have to do the opposite. So you have to increase the frequency, and you have to reduce the amperage and the voltage. And of course, you have to improve everything related to the conductivity of the circuit. Another reason for blood splash can be mycotoxins, is a typical one, but also infections due to bacteria, septicemia, or viruses, viremia. But obviously in these cases you will see other symptoms, not just only the blood splash in the carcass. We know that zinc is very good protecting epithelial tissue and consequently endothelial tissue from the blood vessels. So we conducted a test at the Scottish Agricultural College trying to see if by providing a very good source of zinc, one complex of one amino acid and one metal, we could reduce the incidence of wing hematomas, which is one of the most prevalent lesions we see everywhere in the world. So we give a scoring that is 0 for no problem whatsoever, 1 for mild hematoma, and 2 for big severe hematomas. That means you have to trim the whole wing so that you have a financial penalty. And this is what we saw. We have two groups with the same total amount of added zinc, that is 80 parts per million. The only difference is that in this case it's provided in the form of sulfates or inorganic salts, and in this case it is provided by a mixture of 40 parts per million coming from sulfates and 40 from a vial of zinc, which is this one amino acid, one metal complex. When we see the results, we got astonished, because if we check the scoring of no lesion whatsoever in the wings, we go in the case of the inorganic zinc from 50% of healthy wings to close to 65%. And this is statistically significant. If we go for mild lesions, we come down from 45% of wings to 34.4%, and this is also statistically significant. And if we check the most severe ones, so the degree 2, we go down from 5% to less than 1%, so 5 times less. And this is almost statistically significant. So we had the field observation that we could reduce the hematomas, that in this trial we could demonstrate clearly that we can, by protecting the tight junctions that held together these endothelial cells. So decreasing vascular fragility on the one side, and also avoiding the proliferation of free radical production due to the stimulation of the enzymes that cope with them, like the superoxide dismutase, the catalase, and the glutathione peroxidase. And we can play this trick thanks to the better bioavailability of the zinc, because we manufacture a complex of one amino acid, one zinc, in which the zinc is complex to the amino acid always by the same groups, by the amino group with the carboxylic group, sharing a couple of electrons. That is a covalent bond, covalent coordinated bond to be more precise. And that's it. I hope it can be of help for you, and if so, I am very happy. Thank you very much. Bye.